Covalent modification of enzymes is an important regulatory mechanism. This involves the creation of a new covalent bond or the removal of a covalent bond. Typically, this occurs at residues that have hydroxyl groups like serine, threonine, or tyrosine. The most common form of covalent modification is phosphorylation, which involves adding a phosphate group to a hydroxyl residues in the primary structure of enzymes. The addition of a phosphate is typically accomplished by the action of specific kinases that will phosphorylate specific residues within enzymes. For example, phosphorylation of specific serine and threonine residues is catalyzed by several different kinases, including protein kinase A, protein kinase C, and AMP kinase. The outcome of adding a phosphate group to specific serine or threonine residues usually will have a profound effect on enzyme activity. In some cases, enzyme activity is increased due to phosphorylation, and an example of that is hormone-sensitive lipase, which can be phosphorylated by protein kinase A, which will result in increasing its activity. In other cases, phosphorylation of enzymes on specific serine and threonine residues results in their inhibition. An example of that is glycogen synthase, where glycogenesis will be inhibited due to the phosphorylation of glycogen synthase. Removal of phosphates from specific residues, phosphorylated residues like phosphoserine and phosphothreonine, is also considered a covalent modification because it breaks an existing bond with the hydroxyl group and the phosphate. Typically, this is accomplished by the action of several different phosphoprotein phosphatases. So, in principle, phosphoprotein phosphatases, by removing specific phosphates, can also have remarkable effects on enzyme activity. As an example, dephosphorylation of the enzyme glycogen synthase will activate the enzyme and increase glycogen synthesis or glycogenesis. On the other hand, dephosphorylation of hormone-sensitive lipase responsible for lipolysis of triacylglycerol in adipose tissue results in the inhibition of that enzyme and the inhibition of lipolysis. In summary, the outcome of phosphorylation/dephosphorylation of specific enzymes is dependent on the identity of the specific target enzyme. In some cases, phosphorylation causes an activation. In other cases, phosphorylation can cause an inhibition. Similarly, dephosphorylation in some cases will activate, and dephosphorylations in some cases will inhibit enzyme activities. If you like this video, please subscribe. Thank you.